Okay, now we just spent about 20 minutes, a bit 15, because we had to interpret what all this meant. But we find that everybody here today, and there aren't a lot of people here today, but everybody here today did a really nice job, okay, of almost reasoning it out, okay? In other words, I saw all the details, and I saw a beautiful sketch, and I saw a spontaneously sketched axis of symmetry, even labeled correctly, okay? So it was all very wonderful to see, okay? But let's break this down for everybody because this is kind of mysterious to people, but there should be no mystery at all at this point. And I mean, like after we've been through this example and a couple more, okay? This should tell you everything that you need for this course to know, almost everything about quadratic functions, which are really kind of a pivotal thing in the class, okay? First thing you've seen that's really appropriate pre-calculus material. Not totally. I mean, linear functions are something that you're supposed to get in algebra. You're supposed to come here knowing everything that we studied on linear functions, and almost nobody does. Okay. So here's the problem. Here's a function. Want to find the x-intercepts, find the y-intercepts, find the axis of symmetry, and graph the function. Now this is all, have this process down. It's all very simple, but there's a logic to it. And we want to grasp the logic because what I saw, even though everybody did a beautiful job on this, I had to prompt a couple of times, okay? But with the prompts, okay, well, what I saw was, okay, first, I said find the x-intercept. The first thing you need to think when we say find the x-intercepts is the x-intercept or intercepts occur or occurs. Okay, x-intercepts occur when y equals 0. Okay, that's what it means, because where is y equals 0? Okay, well, let's just get the picture here. Here on the y-axis. Okay. On the x-axis, sorry. Yeah, I can't keep x and y straight. It's just one of the little glitches in my feeble brain here. And it's always been that way. Even my brain wasn't as feeble as it is now. Okay. Even though I was in some pretty high level mathematics daily. You know, okay. I tend to be not, I'm not dyslexic, but I tend to reverse. So everybody's got their little glitches, no matter how much they know or whatever. So don't feel bad if you have a couple, but you need to learn to double check yourself and make sure you don't do anything really stupid as I did in the university physics class yesterday. I did a real bonehead thing. Okay. But I caught it. And after confusing everybody, okay, that's just, yeah. Don't worry if you're making little errors here, although I didn't see a whole lot of errors. Okay, the x-intercept occurs, or the x-intercepts occur when y equals 0. Now our function is x squared plus 4x plus 3. So not block in the board as much. Okay. Now y equals 0. So x squared plus 4x plus 3 equals 0. Well, let's say that equals y. Now y equals 0, so x squared plus 4x plus 3 equals 0. So that X equals -3 or -1. Okay. Now, how do we get from here to here? We use the quadratic formula if we can't factor. And I assume everybody knows how to use the quadratic formula by this point. So I'm not going to put it into this set of reasoning, but I'll go back and both factor it and use a quadratic formula in a minute. So if you don't know how to get from here to here, I'll fill that in. What I want to see is the logic. X-intercept, you're asked to find the X-intercept. You have to know that the X-intercepts occur when Y equals 0. Okay, that's something we've been stressing for a long time. We used it with linear functions because the easiest way to graph a linear function in most cases is to find the intercepts. So you have to know the X-intercept occurs when Y equals 0. That makes it very easy to find the X-intercept of a linear function. And it's equally easy, assuming you can use a quadratic formula and or factor, to find the X-intercepts of a quadratic function. Okay? So the first thing you need to do when you see these questions is, how do you find the X-intercepts? You let Y equal 0. Okay, here's Y equals this. You let that equal 0, and you get this equation, and you solve it. Okay, so the answers are -3, 0. Okay. At this point, we can begin to sketch the graph. So right away, now I prefer to label a vertical line, X equals -1, and then, 3 times as far from the Y-axis, I label X equals -3. And now I have the point -3, 0, because the quadratic formula tells me when X equals -3, Y is 0. Now I should check that. If X is -3, then X squared is 9. 4X is -12. So 9 minus 12 is -3. Add 3, you get 0. Now I'm not going to write that out, but you should. Check this. And check -1, which is easy. You get 1, -4, and 3. 1 and 3 is 4, and you got -4, that gives you 0. Whether you can do that in your head or not, check it. You have to use a calculator to check it, although these numbers are very simple. And you really shouldn't have to use a calculator. So there we have at least a representative graph that shows the X-intercepts. Now, the Y-intercept occurs when X equals 0. Now, if it's a function, you only have one Y-intercept. A function can have as many X-intercepts as it wants. Okay? I can draw a polynomial. We'll see that very shortly. I could draw a polynomial with 10 intercepts. It's very easy. Okay? Okay, the Y-intercept occurs when X equals 0. So X equals 0, Y equals f of 0. And what's f of 0? 0 squared plus 4 times 0 plus 3. Well, that's going to work the same for any quadratic function. X squared and whatever number times x, your x squared and your x terms are going to be 0. You're just going to be left with that one term on the end. So you could shortcut that, but no, write the dang thing out, because you're going to have to reinforce the idea that nobody, almost nobody, has reinforced by this point with what we did for the intercepts of a linear function. Much as I preach it, People do not think x-intercept occurs when y equals 0, y-intercept occurs when x equals 0, and that's fundamental to graphing almost any function. Okay? That's where you start. You don't start with a table that goes from -10 to 10, because the interesting part of the function, like the vertex of your parabola, might be out there at 273, 3,998,000. Okay? And graphing, evaluating it from -10 to 10 doesn't tell you much of anything. A little bit, but not much. Okay, so again, we have to understand how to get x and y intercepts. Okay? It gives you a beginning, so you know how to scale your graph. And if you got your graph marked off from -10 to 10, and the interesting part of the graph doesn't occur anywhere near that interval, you got to start over. Get some information so you know where to put your graph. Okay, now if x equals 0, y equals 3, so the y-intercept is at 0, 3. So what do? We draw the line that shows us y equals 3. And here's our point, 0, 3. Now what do? We draw a parabola through these points, which y'all did beautifully. Okay? I said, draw a parabola through the points. And first, as I just kind of trace it with your pens, or, and so, give me something like this. It wasn't quite right. It went through the 3 points. You had the right idea. So what did I do? I drew 3 points out here without an axis. It said, draw me a parabola through these 3 points. And what I saw was pretty much what I do. So, okay, we got to come down like this, then we got to turn around. So they were pretty shallow here. So I think maybe it was about like this. And it was beautiful. That's okay, now draw it here. Now, usually when I say something, even though it's beautiful here, the scale is different here. It's a little bit shallow here. Okay. But nobody had a bit of trouble. They just kind of did this and said, okay, it's probably going to look about like this, and did a better job than I did. Okay. It was beautiful. Very beautiful. Okay. Now, at that point, I was going to say, okay, well, next, we want to find the axis of symmetry, because of course that's there. Okay. Find the axis of symmetry, then graph the function. Well, actually, we only need those 3 points to graph it, but we still want to have the axis of symmetry. Well, about the time I said, draw the axis of symmetry, I took a close look at the papers. And what did I see? I saw a line halfway between these labeled x equals -2. Well, that's your axis of symmetry. You anticipated the question. It was very, very, very good. Okay. I'm beginning to think that some of the people here might even eke out a passing grade. I'm confident that if we keep working. So this is, we label this is your axis of symmetry. Okay. Now, I believe the parabolas everybody drew out there are a little better than mine, because I kind of lose my symmetry over here. It got a little too steep over here. It's steeper here than it is here, isn't it? Okay. It should be equally steep, meaning it's got a slope here, and it should have the negative of that slope here. So slopes should be equally steep, one going up, one going down. And that could be our test. And that's a test of my parabola. And you look at your parabola, it's going to pass that test better than mine did. Okay? And I'm a master. Well, no. Okay. Got it? So there's our graph. Now, where's the vertex? So I'm going to add one more thing to this. After you've graphed it, want to indicate the vertex. And find the coordinates of the vertex. So can we do, I'm going to give you, and this is something people find a little bit challenging. I will not be a bit surprised if you get it. From what I've seen, it would be unusual for somebody to get this. So I won't be too disappointed if you don't. Okay? I'll get over my depression quickly. Okay? So see if you can do that though. Be excellent if you do, and don't worry if you can't. Well, we're a little bit stuck here because of terminology. We haven't really introduced the term vertex. I think I've used it maybe once or twice. Okay? Okay, the light bulb I think has gone on. So before we start dancing in the streets and so forth to sell. Okay, now one of the most rewarding things I can see is when the light bulb comes on. And as soon as I was in the middle of my sentence, and all of a sudden I saw the light bulb go on. Okay, yeah. And I was going to give you a hint. Well, think red dot. Okay, and that made it very clear. In the context of this course, but the vertex is the highest or lowest point on your parabola. Okay, it's the point where the parabola meets the axis of symmetry. And it's right there. Now, do you know either the x or the y coordinate of the vertex? Okay, now sometimes it takes a little prompting to see what's obvious, but it didn't take much. It said, you know, look at your graph. Do you know one of the coordinates? You know, oh yeah, x equals -2. Okay. So if x equals -2, you don't know what y is, do you? How can you find y? If, no, don't say it because we want to maintain privacy. We don't want you to get caught here. Whatever they're after you for. Okay, so that was pretty wonderful. A little glitch, you know, we gotta convince ourselves that we're really human. So once in a while, we do something a little bit off. But what we've done was very good. Okay. So first of all, you realize that, okay, now we know the x coordinate. How are we going to find the y coordinate? Well, we've got the rule for the function. That's what the function tells us. It tells us if we know what x is, we find what y is. So we've indicated the vertex. We want to find the coordinates of the vertex. So the vertex x equals -2. But we need the y coordinate. How do we find the y coordinate? Well, if x, f of x tells us how to find y. If we know x, right? It's a vertex, y equals f of -2. Because that's the x coordinate of the vertex. We don't have to write f of x. Y equals f of -2, and we can look over at the rule for the function and see that's going to be the square of -2 plus 4 times -2 plus 3. Now, -2 squared, and this is an error people made, but as beautifully as we're doing so today, and all the hard stuff. Somebody said -2 squared is -4. Okay? Lack of focus on really what's going on there. Don't feel bad, just fix it because it's easy. What's -2 times -2? Well, if you multiply a negative by a negative, it's positive. That's -2 times -2. And you're going to get a positive 4, which I'll emphasize by putting the plus in front, which is actually unnecessary, but we want to emphasize. And then it's -8 plus 3 equals 1. Well, now our group is really complete. Text says, finding your center point. Other points are also important. Now, see, I made a sign error there too. I said 1, it's -1. If I got 1, that wouldn't be very consistent with my graph, because if my x-intercepts are here, my y-intercept is here, my vertex has to be down below the x-axis, doesn't it? Okay, so it wouldn't have made any sense to write -2, 1, so I caught myself in a careless error. Okay, and you're always looking for careless errors because we all make them. And you're lucky to have me for an instructor because I make so many of them, so I can demonstrate how to catch them. Okay, well, okay, I should probably make fewer, but it does have the advantage that I get to emphasize the fact that you're going to make errors too. Everybody's going to make errors. Question is whether you check for consistency and catch them. Okay. You know, you're probably going to be dealing with AI, if not already. Okay. Well, AI makes mistakes and it always will. Now it's going to probably stop making math mistakes in the near future. Probably already has, if you use the right AI. But it'll make conceptual mistakes. It'll make mistakes where things are not consistent. And you're going to say, wait a minute, you just told me this, now you're telling me this. Is that really consistent? And then you got to ask, hey, can you clarify this? Didn't you say this and this? Isn't that inconsistent? Then it'll either convince you that it's consistent, and maybe it's going to make up some reason for it to be consistent. But most likely, if it is inconsistent, it's going to say, oh, darn, you're right. Okay. And if it was actually consistent, it'll probably confuse you with a more sophisticated argument that you're going to have to pin it, that you're going to have to nail it down on. Okay. You don't just accept what it says. Never accept what it says. And that goes for people too. That goes for your own thinking. Okay. Test everything. Make sure you've got it right, or as right as is humanly possible. Okay. So give the aside, but right there is a good picture of this quadratic function. Okay. Now let's go on with this example, because being able to graph a quadratic function is one of the keystone things, and to interpret a quadratic function and to understand what it's telling you. That's a keystone thing in pre-calculus. Okay. Now, in a really, really good Algebra 2 course, we have a select group of students who can actually understand everything. You can do that. You can do this, but since we're trying to teach algebra to people who will never understand it, it's rare that we get this far in algebra 2. Okay. So what we want to do is value of x, value or values of x is y equal to 2. Can you estimate that based on your graph? I'm going to say estimate, then calculate. Okay, so how do we estimate the value of x, or the values where y equals 2? Well, everybody did a really nice thing here. They drew the line y equals 2. And it cuts the graph in 2 points. Here's y equals 2. Now, do I have that right? Maybe it's a little bit high, but still it's representative, right? And if we're a little bit high or a little bit low, we're still going to get a reasonable estimate. And now what I do is I take this point and I sketch a vertical line through this point. And I take this one and I sketch a vertical line. Now, I think this one, if this is 1, that looks like it's about 0.3. So I'm going to say, okay, this line is x approximately 0.3. So now we get 2 estimates. Now, if that's 0.3, that's only 7/10 of a unit from here, right? Now, this one looks like it's too far that way, which is a little weird because I thought the graph was steeper on this side than this side, but my graph isn't totally symmetric. If my graph was totally symmetric, this distance here would be the same as this distance here. And this distance looks like it's about twice as far. So I'm going to say that this looks like about x about -4. And I didn't put my negative on this 0.3. There it is. My negative in this. Now, I know these can't both be correct because of the symmetry. From the axis of symmetry, the negative 0.3 is 1.7 units. And from the axis of symmetry to here is 2 units, okay? But that's an anomaly of my sketch. I'm getting estimates. I know the estimates aren't totally correct. Now I can plug these numbers in. And I'll do that later, but if I check the estimates, x equals -4, I would have -4 squared, which is 16. And then negative 12, which leaves me 4, and then 3, which gives me 7. Okay? So I get 7 instead of 2 if I put in negative 4, if I did that correctly. If I put in negative 0.3, I get 0.09, 1.2, and then I get 1.9, 1.9 or 2.1. I get something very close to 2 when I do this. Okay? So let's just see what they should be though. How do we actually calculate? Okay, I'll put a blue circle around this to see that it came from an estimate. Let's calculate. Well, so if we do y equals x squared plus 4x plus 3, we get this equation, right? Now, usually we want our x's on the left and our numbers on the right. So I'm going to put this in the form x squared plus 4x plus 3 equals 2. Now, I'll give you a chance to cover yourself with glory here, but 99% of people, if they haven't seen this, aren't going to get it. So don't feel badly if you don't. But you're doing so well, I got to give you the chance. I hit the button. I have the cursor right on, and okay. One of these days I'll learn to operate that thing. Okay. So what we do is we solve for x. Well, I'll give myself room to do this. So I'm going to rewrite the equation x squared plus 4x plus 3 equals 2. Now, the quadratic formula only applies if I've got 0 over here. And I already put 0 there, it's supposed to be 2. That only applies if I've got 0 there. Okay? This full statement of the quadratic formula that I use is ax squared plus bx plus c equals 0 if and only if x equals this, okay? So it's got to be a quadratic expression equal to 0. So what can I do to this? How can I get this as a quadratic function that's equal to 0? By using some valid mathematical operation. Okay, so we have this equation. We want to use the quadratic function. So we need to get a 0 on this side. Now, what do we do? What can we do to both sides of this equation to get a 0 on this side? Well, let's just try something. Let's say we multiply both sides by 5. Well, if we multiply both sides by 5, plus 20x plus 15 equals 10. Well, that didn't give us 0, but 10 did have a 0 on it. Maybe we can just cross out that 1. No, we can't do that. Okay? Multiplying both sides isn't going to change that 2 to 0 unless we multiply by 0. But if we multiply by 0, we lose all our information, because the left-hand side would then be 0 and the right-hand side would be 0. So we can't multiply both sides by 0. We never do that, because if we've got any information at all in the equation, we're always going to get 0 equals 0, and that removes all possible information. Okay? So think about dividing. Well, that's not going to work. Well, we subtract. If we subtract 2, as people like to do, we'll do it this way. We subtract 2 from both sides, meaning we subtract the equation, negative 2 equals negative 2. We want to be sure we see that. We get x squared plus 4x plus 1 equals 0. Now, we're going to use a quadratic formula. x equals negative b plus or minus the square root of b squared minus 4ac over 2a, where we note that a equals 1, that's a coefficient of x squared, b equals 4, coefficient of x, and c equals 1. So now we get negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 1, all divided by 2 times 1, which is negative 4 plus or minus the square root of 12. If we do the arithmetic, 4 times 1 is 4. 4 squared is 12. 12 minus 4, 16. 16 minus 4 is 12. And that's all divided by 2. Okay? Now, we would ordinarily simplify the square root of 12 as the square root of 4 times the square root of 3. Square root of 4 is 2. That would be 2 times the square root of 3. But I'm just going to cut right to the calculation. I'm going to write it this way, negative 4 over 2 plus or minus the square root of 12 over 2, which is negative 2 plus or minus. Square root of 12, I think, is pretty close to 3.4, because 3.5 squared is 12.25. Okay, square 3.5, you get 12 over 40. So I think it's a little less than 3.5. I think it's 3.4. And that's then going to be 3.4 divided by 2, pretty close to 1.7. If you plug it into your calculator, you'd actually get 1.732. Now that 1.732 comes from the fact that I know this is 2 times the square root of 3 and divided by 2 is just the square root of 3. And everybody in my generation knows what the square root of 3 is. Okay? The 3, 4 significant figures. So this is negative 2 plus 1.7 or negative 2 minus 1.7, which equals negative 0.3. Now, I calculated this for 0.3 and said it's pretty close to 0, okay? If we plug in 0.3, we get something pretty close to 0. So this solution checked out very nicely. It matches this solution, but I don't have the 0.732, okay? So that should actually be negative 2.617. My feeble brain isn't quite there. I could easily calculate it, but not that easy. Negative 3.7. Now these are approximations, because when I do the square root, I am going to just get an approximation. Now I note that I got to negative 0.3 here. You got negative 3.7 for your estimate over here. Okay, whereas my estimate, usually, if I'd have done an honest estimate, probably did in a little more than negative 4. There's like 14.1. Okay, so your parabola is better than mine over there. Mine was over here. Okay, still, overall, yours is better. Okay, so there we have our 2 solutions. And these 2 solutions match up well with our estimates. Negative 0.3 actually matches this estimate based on this graph, and negative 3.7 is pretty close to negative 4. Well, I think we did pretty well between us. Okay. Well, that's a whole lot of what you do with quadratic functions. Now, you can also calculate rates of change on an interval and stuff like that. Okay. And you have to know how to do that for the test that you're going to have to do. Okay. This week or later. But there it is. Okay. And that's just a nice I think it's compact picture of what you can do with quadratic functions. Now, the other thing I said we could do that we usually don't do if we actually encounter a quadratic function in the wild. In other words, a quadratic function occurs in the real world. They never factor. So why do we learn to factor? Well, there are good reasons to learn to factor. So we might as well reinforce factoring, even though for practical purposes for quadratic functions applied to the real world, factoring is almost worthless. But it is worthwhile for some of the stuff that's coming up. So let's just fill in a few blanks. Okay. First of all, solve x squared plus 4x plus 3 equals 0, which we did over here. This is true if and only if x is one of the values that you get from the quadratic formula. Now, I identified the a, b, and c for the quadratic formula here. A is a coefficient of x squared, b is a coefficient of x. C is that number that's left over. Open math tells you that. Everybody in the world tells you that. And people don't have any problem with it. So I'm going to assume there's no problem here. B is a coefficient of x squared, which is -1. Now you want to write it out, and yeah, probably I ought to write it out. You identify. And I just messed it up. I just wrote something wrong. Okay, so A is 1, B is 4, C is 3. X is -b, which is -4, plus or minus the square root of 4 squared minus 4 times 1 times 3. All divided by 2 times 1. And that equals -4 plus or minus the square root of 4. That's 12. That's 16 minus 12, which is 4, over 2, which is -4 plus or minus 2 over 2, which is -4 plus 2 over 2, or -4 minus 2 over 2, which is equal to -1 or -3. Okay, now that's all consistent because, you know, still in the dark about how we get these results, -3 or -1, the quadratic formula gives us those results. Okay. And I said over here, I'm going to assume everybody can use a quadratic formula and or factor this. Now this can actually be factored. So x squared plus 4x plus 3 equals 0 means, well, you need two factors of 3. Now, I think the first thing a lot of people did here was try to factor this. They were maybe looking at factors of 4, like 4 and 1, of 2 and 2, or something like that. You look at factors of 3. And I'm not going to go into the detail how you factor, but the number here and the number here, if you use a distributive law, how are you going to get 3? You got to have 3 and 1. And if it's integers, 3 and 1 is the best you're going to do. Okay? So you could put this with a question mark. But if you then multiply it out, you see that it does work. X times X gives you the X squared, 3 times X, and 1 times X gives you the 4X, and 3 times 1 gives you the 3. And we'll worry about that when we cover just a little bit of factoring. Factoring is something people usually are fairly decent at after they come out of the secondary curriculum, okay? And in my opinion, there are more important things they should be good at. But everybody should be good at factoring, so I don't have too much of a problem with that. Okay, so anyhow, if you have this, how do you get a solution to this? The only way two numbers can multiply to give you 0 is if one of them is 0. So either this has to be 0 or this has to be 0. If they're not both 0, you're not going to get 0. So this tells you that x plus 3 is 0 or x plus 1 equals 0. Well, this gives you x equals -3. And this gives you x equals -1, the same as a quadratic formula. And the key thing you have to see here, and the reason I even bothered to do the factoring, is because you have to understand that when you have a product of two things that's equal to 0, one of those things has to be 0, and it can't be, unless they're the same, it can't be both. Okay? So that's how you use factoring. And you were on that track. Okay. Well, I think that was all very good. I hope Zoom actually worked right, so we have a good recording of